Haplogroup R1a, or Haplogroup RM420, is a Y-DNA haplogroup which is distributed in a large region in Eurasia, extending from South Asia and southern Siberia to Central Europe and Scandinavia. The distribution of R1Z282 in Eastern Europa and R1-Z93 in Asia suggests that R diversified within the Eurasian steppes of the Middle East and Caucasus region or in the vicinity of present-day Iran. The SNP mutation RM420 was discovered after RM17, which resulted in a reorganization of the lineage, in particular establishing a new paragroup for the relatively rare lineages which are not in the RSRY1083.1.2 branch leading to RM17. Origins. The modern distribution of R1a has two widely separated areas of high frequency: South Asia and Eastern Europe. Some researchers have claimed that South Asian populations had the highest street diversity within R1a. Other studies have proposed Eastern European, Central Asian, and even West Asian origins for R1a. According to Panjab et al., Inner and Central Asia is an overlap zone for the R1a1Z280 and R1a1-Z93 lineages, implies that an early differentiation zone of R1a1M198 conceivably occurred somewhere within the Eurasian steppes of the Middle East and Caucasus region as they lie between South Asia and Eastern Europe. A large 2014 study by Peter A. Underhill et al., using 16,244 individuals from over 126 populations from across Eurasia, concluded there was compelling evidence that the initial episodes of haplogroup R1a diversification likely occurred in the vicinity of present-day Iran. Phylogeny. The R1a family tree now has three major levels of branching, with the largest number of defined subclades within the dominant and best-known branch, R1a1a. Topology. The topology of R1a is as follows: Haplogroup RM173. R1a, distinguished by several unique markers including the M420 mutation, is a subclade of haplogroup RM173. R1a has the sister subclades haplogroup R1b M343 and the paragroup RM173*. RM420 defined by the mutation M420, has two branches. RSRY1532.2, defined by the mutation SRY1532.2, which makes up the vast majority, and RM420*, the paragroup, defined as M420 positive but SRY1532.2 negative. Mutations understood to be equivalent to M420 include M449, M511, M513, L62, and L63. Only isolated samples of the new paragroup RM420* were found by Underhill 2009, mostly in the Middle East and Caucasus. 1/121st Omanis, 2/150th Iranians, 1/164th in the United Arab Emirates, and 3/612ths in Turkey. Testing of 7,224 more males in 73 other Eurasian populations showed no sign of this category. RSRY1532.2. R1a1 is defined by SRY1532.2 or SRY10831.2, understood to always include SRY10831.2, M448, L122, M459, and M516. This family of lineages is dominated by M17 and M198. In contrast, paragroup RSRY1532.2* lacks either the M17 or M198 markers. The RSRY1532.2* paragroup is apparently less rare than R1*, but still relatively unusual, though it has been tested in more than one survey. Underhill et al. Reported 151st in Norway, 305th in Sweden, 157th Greek Macedonians, 150th Iranians, 734th ethnic Armenians, and 141st Kabbatians. Sahu et al. Reported RSRY1532.2* for 115th Himachal Pradesh Rajput samples. RM17 M198. The following SNPs are associated with R1a1a, R1a1a1. R1a1a1 is the most widely found subclade, in two variations which are found respectively in Europe and Central and South Asia. Underhill 2014-2015. R1a1a1b1a. This large subclade appears to encompass most of the R1a1a found in Europe. R1a1a1b1a occurs in northern Ukraine, Belarus, and Russia at a frequency of ~20%. R1a1a1b1a3 occurs in northwest Europe and peaks at ~20% in Norway. R1a1a1c is apparently rare. It was found in one of 117 males typed in southern Iran. R1a1a1b1a1 RM458 is a mainly Slavic SNP, characterized by its own mutation, and was first called cluster N. Underhill et al. Found it to be present in modern European populations roughly between the Rhine catchment and the Ural Mountains, and traced it to a founder effect that falls into the early Holocene period. 7.9 plus or minus 2.6 KYAM458 was found in one skeleton from a 14th century grave field in Usedom, Mecklenburg-Vorpommern, Germany. The paper by Underhill et al. also reports a surprisingly high frequency of M458 in some northern Caucasian populations. R1a1a1b1a1a. R1a1a1b1a1a, commonly referred to as West Slavic or Polish, is a subclade of the larger parent group RM458, and was first identified as an street cluster by Pavlovsky 2002 and then by Gwozdz 2009. Thus, RL260 was what Gwozdz 2009 called cluster P. In 2010 it was verified to be a haplogroup identified by its own mutation. It apparently accounts for about 8% of Polish men, making it the most common subclade in Poland. Outside of Poland it is less common. In addition to Poland, it is mainly found in the Czech Republic and Slovakia, and is considered clearly West Slavic. The founding ancestor of RL260 is estimated to have lived between 2,000 and 3,000 years ago, i.e., during the Iron Age, with significant population expansion less than 1,500 years ago. RM334C. Q. R1a1a1b1a1 was found by Underhill et al. Only in one Estonian man and may define a very recently founded and small clade. R1a1a1b1a2 R1a1a1b1a2b3*. R1a1a1b1a2b3* is a street-based group that is RM17. This cluster is common in Poland but not exclusive to Poland. R1a1a1b1a2b3a R1a, 1a, 1b, 1a, 2b, 3a was early called Cluster G. R1a, 1a, 1b, This large subclade appears to encompass most of the R1a, 1a found in Asia. R1a, 1a, 1b, is most common in the South Siberian Altai region of Russia, cropping up in Kyrgyzstan and in all Iranian populations. R1a, 1a, 1b, 2a*. This subgroup occurs at highest frequencies in Kyrgyzstan and in Afghan Pashtuns, at a frequency of NGT 10%. It is also observed in other Afghan ethnic groups and in some populations in the Caucasus and Iran. RM434 is a subclade of Z2125. It was detected in 14 people, all in a restricted geographical range from Pakistan to Oman. This likely reflects a recent mutation event in Pakistan. R1a, 1b, 2a, 1*, 1 Hazara, and 1 Iranian Azerbaijani. R1a, 1b, 2a, 2* occurs at high frequency in South Asia, India, Pakistan, Afghanistan, and the Himalayas. The group also occurs at NGT 3% in some Iranian populations and is present at NGT 30% in Roma from Croatia and Hungary. Geographic distribution of R1a, 1a. Asia, Central Asia. In Afghanistan, R1a, 1a is found at 51% among the Pashtuns, who are the largest ethnic group in Afghanistan, 50% among the Kyrgyz, and 30% among the Tajiks. It is less frequent among the Hazaras and the Turkish-speaking Uzbeks. South Asia. In South Asia, R1a, 1a has often been observed with high frequency in a number of demographic groups. In India, high frequencies of this haplogroup is observed in West Bengal Brahmins to the east, Kinganista Brahmins to the west, Khatris in the north and Iyengar Brahmins in the south. It has also been found in several South Indian Dravidian-speaking Adivasis, including the Chenchu and the Valmikis of Andhra Pradesh and the Kala of Tamil Nadu, suggesting that R1a, 1a is widespread in tribal southern Indians. Besides these, studies show high percentages in regionally diverse groups such as Manipuris to the extreme northeast and in Punjab to the extreme northwest. In Pakistan it is found at 71% among the Mohana tribe in Sindh province to the south and 46% among the Baltis of Gilgit-Baltistan to the north. Among the Sinhalese of Sri Lanka, 23% were found to be R1a, 1a positive in a sample size of 87 subjects. Hindus of Terai region of Nepal show it at 69%. East Asia. The frequency of R1a, 1a is comparatively low among some Turkish-speaking groups, including Turks, Azeris, Kazakhs, and Yakuts, yet levels are higher in certain Turkic or Mongolic-speaking groups of northwestern China, such as the Bonan, Dongxiang, Salar, and Uyghurs. In eastern Siberia, R1a, 1a is found among certain indigenous ethnic groups, including Kamchatkans and Chukotkans, and peaking in Itelmen at 22%. West Asia. R1a, 1a has been found in various forms in most parts of Western Asia, in widely varying concentrations, from almost no presence in areas such as Jordan, to much higher levels in parts of Kuwait, Turkey and Iran. The Shamar Bedouin tribe in Kuwait show the highest frequency in the Middle East at 43%. Wells 2001 noted that in the western part of the country, Iranians show lower R1a, 1a levels, while males of eastern parts of Iran carried up to 35% R1a, 1a. Nasidze 2004 found R1a, 1a in approximately 20% of Iranian males from the cities of Tehran and Isfahan. Ruggiero 2006 in a study of Iran noted much higher frequencies in the south than the north. A newer study has found 20.3% RM17*, asterisk among Kurdish samples which were taken in the Kurdistan province in western Iran, 9.7% among Mazandaranis in North Iran in the province of Mazandaran, 9.4% among Gilaks in province of Gilan, 12.8% among Persian and 17.6% among Zoroastrians in Yazd, 18.2% among Persians in Isfahan, 20.3% among Persians in Khorasan, 16.7% Afro-Iranians, 18.4% Kashmir, 21.4% among Persian-speaking Bandari people in Hormozgan, and 25% among the Baloch people in Sistan and Balochistan province. Further to the north of these Middle Eastern regions, on the other hand, R1a levels start to increase in the Caucasus, once again in an uneven way. Several populations studied have shown no sign of R1a, while highest level so far discovered in the region appears to belong to speakers of the Karachi-Balkar language, among whom about 1/4 of men tested so far are in haplogroup R1a. Europe. In Europe, the R1a subclade is found at highest levels among peoples of Eastern European descent. In the Baltic countries, R1a frequencies decrease from Lithuania to Estonia. Levels in Hungarians have been noted between 20 and 60%. There is a significant presence in peoples of Scandinavian descent, with highest levels in Norway and Iceland, where between 20 and 30% of men are in R1a. Vikings and Normans may have also carried the R1a lineage westward, accounting for at least part of the small presence in the British Isles. In East Germany, where haplogroup R1a reaches a peak frequency in Rostock at a percentage of 31.3%, it averages between 20% to 30%. Haplogroup R1a was found at elevated levels among a sample of the Israeli population who self-designated themselves as Levites and Ashkenazi Jews. Buhar reported R1a to be the dominant haplogroup in Ashkenazi Levites, although rare in Ashkenazi Kohanim. In southern Europe, R1a is not common, but significant levels have been found in pockets, such as in the Par Valley in northern Spain, areas of Venice, and Calabria in Italy. The Balkans shows lower frequencies and significant variation between areas. For example, and GT, 30% in Slovenia, Croatia and Greek Macedonia, but LT, 10% in Albania, Kosovo and parts of Greece. The remains of a father and his two sons, from an archaeological site discovered in 2005 near Ulan dated to about 2600 BCE, tested positive for the YSNP marker SRY108331.2. The E-search number for the Ula remains is 2C46S. The ancestral clade was thus present in Europe at least 4,600 years ago, in association with one site of the widespread corded ware culture, R1a and the Indo-Europeans. The question of the origins of R1a is relevant to the ongoing debate concerning the Heimat of the Proto-Indo-European people, and may also be relevant to the origins of the Indus Valley Civilization. R1a shows a strong correlation with Indo-European languages of Western Asia and Eastern Europe, being most prevalent in Poland, Russia, and Ukraine, and also observed in Pakistan, India and Central Asia. The connection between YD and ARM17 and the spread of Indo-European languages was first noted by T. Zergel and colleagues in 1999. Ornelas Emino and colleagues proposed a post-glacial spread of the R1a gene during the late glacial maximum, subsequently magnified by the expansion of the Kurgan culture into Europe and eastward. Spencer Wells suggests that the distribution and age of R1a points to an ancient migration corresponding to the spread by the Kurgan people in Their expansion from the Eurasian steppe, Europe. Haplogroup R1a has been found in the remains of people of the Cordillera culture and Urnfield culture, as well as the burial of the remains of the Andronovo culture, the Pazyryk culture, Tagar culture and Tashtik culture, the inhabitants of ancient Tano, in the Tarim mummies, the aristocracy Jormu. South Asia. According to Underhill et al., the diversification of Z93 and the early urbanization within the Indus Valley also occurred at, and the geographic distribution of R1a M780 may reflect this. Posnick et al. Note that striking expansions occurred within R1a Z93 at 4500–4000 years ago, which predates by a few centuries the collapse of the Indus Valley civilization. Mascarenas et al. Note that the expansion of Z93 from Transcaucasia into South Asia is compatible with the archaeological records of eastward expansion of West Asian populations in the 4th millennium BCE, culminating in the so-called Kuro-Araxes migrations in the post-Uric IV period. According to Lazaridis et al., farmers related to those from Iran spread northward into the Eurasian steppe, and people related to both the early farmers of Iran and to the pastoralists of the Eurasian steppe spread eastward into South Asia. They further note that Ani can be modeled as a mix of ancestry related to both early farmers of western Iran and people of the Bronze Age. Eurasian steppe. Popular Science. Brian Sykes in his book Blood of the Isles gives imaginative names to the founders or clan patriarchs of major British Y haplogroups, much as he did for mitochondrial haplogroups in his work The Seven Daughters of Eve. He named R1a in Europe the clan of A patriarch Sigurd, reflecting the theory that R1a in the British Isles has Norse origins. Historic naming of R1a. The historic naming system commonly used for R1a was inconsistent in different published sources, because it changed often. This requires some explanation. In 2002, the Y chromosome consortium proposed a new naming system for haplogroups, which has now become standard. In this system, names with the format R1 and R1a are phylogenetic names, aimed at marking positions in a family tree. Names of SNP mutations can also be used to name clades or haplogroups. For example, as M173 is currently the defining mutation of R1, R1 is also RM173, a mutational clade name. When a new branching in a tree is discovered, some phylogenetic names will change, but by definition all mutational names will remain the same. The widely occurring haplogroup defined by mutation M17 was known by various names, such as U19, as used in the older naming systems. The 2002 YCC proposal assigned the name R1a to the haplogroup defined by mutation SRY1532.2. This included U19 as a subclade, so U19 was named R1a1. Note: SRY1532.2 is also known as SRY10831.2. The discovery of M420 in 2009 has caused a reassignment of these phylogenetic names. R1a is now defined by the M420 mutation. In this updated tree, the subclade defined by SRY1532.2 has moved from R1a to R1a1, and U19 from R1a1 to R1a1a. More recent updates recorded at the ISOGG reference webpage involve branches of RM17, including one major branch, RM417. In art, Artem Lukashev created an animation based on the Bashkir epic about the Ural, which outlined the history of the clusters of haplogroup R1, R1a and R1b.